All right, let's look at the homework 15.4, problem number 10. All right, so let's evaluate this double integral using polar coordinates. All right, so first, let's sketch the region here. So we have, all right, so here we're doing the integral with respect to y. So this is going to be actually y equals, oops, I'm going to use a different color here, y equals 0. And this is y equals square root of 2x minus x squared. And then these are x values. So x equals 0 and x equals 2. All right. All right. So let's look at the y is equal to, all right, square root of 2x minus x squared. All right. We can complete the square so that we can sketch the picture of this. All right, so I'm going to pull out the negative sign from negative x squared. So you have x squared. So 2x becomes a negative 2x. All right, so in order to complete the square, I'm going to, let's see, we're going to need a plus 1 here. Then I'm going to subtract 1 so that we don't change the function. So using these three terms, we can write it as square root of, right? So it's a negative. So that part, those three terms is x minus 1 quantity squared, right? So you have a negative 1 left over. You have another negative sign, so negative 1, so it's a positive 1. So it looks like that. So you can see that this is actually a top semicircle shift with radius 1 and shifted to the right 1 unit. All right, so we have a picture which looks kind of like this. All right, here is the x-axis. All right, here is the y-axis. All right. So it's just a semicircle with radius 1 and center is at the 1. So we have a semicircle and it's a unit circle here. Right. Then the region is from 0 to that semicircle. X is going from 0 to 2. So 0 to 2 right here. So we're talking about this region. Half of the disk here with radius 1. All right, so what we want to do is we want to rewrite this in polar coordinates. So this is going to be equal to, oops, a different color. All right, so this is going to be equal to, all right, so we have a double integral. All right, so we know that, x squared plus y squared is r squared, and with the square root it's going to be just 4 times r, so we get 4r. All right, and then we have our area element is r dr d theta, so there's another r, so it's a r squared, so we have a dr d theta. Right, then we have to find the the bounds here. All right, so to find the bounds for r, what we do is we're going to visualize the fixing theta. So theta, all right, fix theta. And r has to go from 0 up to here. So we know that the lower limit is going to be 0, equals 0, right? Then upper limit is going to be determined by this semicircle. So we have to rewrite this semicircle in polar coordinates. All right, so let's do this. If you square both sides, you're going to get the, let's see, we're going to have y squared is equal to 1 minus x minus 1 squared, right? Actually, better yet, maybe I'm going to do this. Hold on a sec. Actually, I'm just going to use the original one. So it's going to be 2x minus x squared. Right? So that's the equation. And then I'm going to turn into polar coordinates. So you have y is r r sine of theta. So you have r squared and the sine squared of theta, which is equal to 2 times x is r cosine of theta minus x squared would be r squared cosine squared of theta, right? Then I'm going to move this term over to the other side, so I'm going to add r squared cosine squared of theta. So we get the r squared cosine squared of theta, and we have r squared sine squared of theta, which is equal to 2r cosine of theta. All right, then we know that here, if you pull out the r squared, you have cosine squared theta plus a sine squared of theta, which is equal to 2r cosine of theta, right? Then one thing we should notice that the cosine squared plus sine squared is equal to 1. And another thing is that there's r on both sides, so divide through by r, we get this, right? So the equation for this semicircle in polar coordinate would be r equals 2 times cosine of theta, right? So this equation here, so this is r equals 2 cosine of theta. So the bound is going to be 2 cosine of theta, right? Then once you've done that, the angle is going to be, so in order to swipe the whole thing, you're going to start with the angle 0. So this will be theta equal to 0. Then increase the angle little by little. And in order to cover the entire region, you have to go up to pi over 2. So this is theta equals pi over 2 there. Theta equals 0 there. So theta is going to go from 0 to pi over 2. All right. So all you have to do is evaluate this integral. Right. So let's do that. All right. So this is going to be equal to, right. So outside I'm going to leave this as it is, pi over 2. All right. So antiderivative of that would be, let's see, 4 is there, and you have add 1 to the power, divide by that power. Right. Then you're going from 0 to 2 cosine of theta, right? Then we're going to have to do d theta. All right, so what you get is going to be integral from 0 to pi over 2. Right, plug in 2 cosine theta, so 2 cubed is 8, and 4 times 8 is 32. Over 3. Then you have a cosine cubed of theta, d theta. All right. Then we just have to integrate this, but here I'm going to move this constant outside there. So we have 32 over 3, right? Then you have an integral from 0 to pi over 2. Right, so I'm going to break it into this cosine cubed. So I'm going to put the 1 of the cosine out here. Right, then you would have cosine squared. And a cosine squared can be written as 1 minus sine squared, using the trig identity with respect to theta. Here, I'm going to use a substitution. I'm going to let u be equal to sine of theta. Then if you take the derivative of u with respect to theta, we get cosine of theta. If you take the reciprocal, you get d theta over du is equal to 1 over cosine of theta. Then I'm going to multiply through by du, so that the d theta is equal to du over cosine of theta, right? the bound is theta is going from 0 to pi over 2. So u is going to be sine of 0 is 0, sine of pi over 2 is 1. So this integral becomes 32 over 3. Then you have an integral from 0 to 1. And I'm going to leave cosine of theta right here. Then we have 1 minus sine, u is sine, so it's a u squared. And d theta is equivalent to du over cosine of theta. So you can see that we can cancel cosine of theta on top and a cosine of theta on the bottom. Then we have that. Then we have 32 over 3. So antiderivative of 1 is u. Antiderivative of u would be u cubed over 3. Then you're going from 0 to 1. All right? So this is going to be equal to 32 over 3. Right? Plugging 1, so you get 1 minus 1 over 3. So it's at 2 over 3. And plugging 0, it's going to be 0. So what you get is going to be 64 over 9. All right? So let's type it in. So we got 64 over 9. All right? Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.